In this video we are going to take one step further with our differentiation and look at how we differentiate functions which first need some more manipulation to them, such as expanding brackets or dividing. So let's just go through a few examples which you'll find on your notes sheet. So if we have f of x equals 3 root x and we're asked to find an expression for the rate of change of y with respect to x, that just means find the gradient function, differentiate. So in order to know how to differentiate this root, we need to change it into index form. So we know that square root is the same as the power of a half. So f of x there is 3x to the half. Now we can differentiate to find the gradient function. So we're just dealing with fractions here. So bring down the power and multiply it by the 3. So that gives me 3 over 2. X, reduce the power by 1, so that's going to be minus a half. If we wanted to put that in fraction form instead of negative index form, that would be 3 over 2 x to the power of half. Again, we could, if we needed to, rewrite that in its square root form. But again, not necessary unless it's a show that question. If it's not a show that question, it's perfectly okay to leave your answer in this form here. If we have brackets in our original function, first thing we need to do is a bit of manipulation on the original function and expand the brackets. So we'll get x to the 5, remember we're multiplying, so we add the powers, minus 4x cubed. Now we can easily differentiate each term. So we've got 5x to the 4 minus 12x squared. So any brackets, expand them first. So this last one I want to show you today, if we have an algebraic fraction, we have to simplify it first. We have to actually do this division. So if we just factorise the numerator. In fact, here I'm just going to take out 1x so that I can cancel it with the x on the denominator. So that will leave me with x to the 4 plus x over x. Now I can simplify my algebraic fractions by cancelling those x's. So my original function that I'm trying to differentiate is x to the 4 plus x. So now I'm in a form where I know I can differentiate, and dy by dx is 4x cubed plus, so if we differentiate 1, the coefficient of the if we differentiate x, the coefficient there is 1, so that's just 4x cubed plus 1. What I'd like you to do just before you start the questions today is, in your notes books, I want you to do a differentiation take 4. So of all the things that we have looked at so far, just write down 4 key points that you think are important to remember. So just pause the video and do that now. So you've written down your 4 takeaways for differentiation so far. So now I'd like you to have a go at the exercise 8b in your further maths textbook, questions 1, 2 and 3.